The machine is this, a research project to rethink how we do computing from the ground up. We're leading the industry once again, and we hope you will join us for the ride.
Martin was saying how everything they were selling today was going to change.
This is provocative. This is something that is the answer to an existential question that sometimes you don't want to ask.
So we were scared to see if people were going to declare us crazy. We were excited because we thought we weren't.
It always starts at a pie in the sky. And the real exciting part of this job is to see that pie in the sky become actual reality. And that's what we are doing with the machine.
Let's imagine you're now building the world's very first computer. The twist is you now have access to all of the technology that exists today. Would you build that computer the same way that we have for the past 60 years? I was convinced that the answer to that question was absolutely not.
It's no longer about the computing, it's about the data and the memory and where it is in the middle of everything. All the computing you do on that, but you do it from the outside.
We're basically saying everything you've got fits all into memory, all at the same time. And so we have simulated some of those things using some of our current equipment like Superdome X.
And I can now make applications run 100 to 200 times faster than it was possible. I can make these applications scale to a size that we have never seen before, and they're just as fast. And that just opens up so many possibilities. It's like walking into a new world.
The airlines have an incredibly difficult problem to solve, and I would love to be able to go and apply that machine architecture.
The challenge of transportation systems is we have conventional technologies that help us plan. But as soon as one thing goes wrong, that plan goes out the window. One pilot misses his connection. That means he can't fly the next one. That means the airplane isn't there. And suddenly, this one little failure, this one little problem has cascaded throughout the entire transportation system. But instead of just solving the one problem, we'll think of what's the next most likely thing to go wrong, and we'll solve that problem. And we'll think of the next one, and we'll solve that one. And so you go out in this series of cascading what-ifs, imagining all the things go wrong, and you calculate the plan. And because you have huge amounts of memory, you can keep all these plans for immediate use. And if I can decide in real time, then my problems can stay containable.
It's going to be amazing to see what applications are really going to change the world once this gets out there. And the more we look at it, the more and more we say it's going to apply everywhere.
But I have to keep my feet on the ground even though my head is in the sky, because you can see that becoming a shared dream, not just a dream in one person's mind.
You can't do something this revolutionary and be safe. And that's one of the things I think is most exciting, to take that risk and address it and work with great people that aren't afraid to do that.
Last year in London at Discover, just hearing the excitement, I'm like, wow, you should see the stuff that we have that really works right now and we can't show you yet.
This amazing thing that we're building together has become real, and the potential of that is huge.
When my kids need to make decisions, they will have tools to not just survive, but to thrive. And really that's what the machine is trying to do.
To solve problems that we can't even dream to solve today.
All right, looks good. Heartbeats are on.
When you think about the amount of progress we have made over the last 50, 60 years using computers, every so often a miracle happens and then we continue moving forward. I think I'm part of the next miracle.